Assessment of reduction in water spread of Shanthisagara Lake in Davanagere district Karnataka using Geoinformatics. Abstract. The aim of present study is to assess the causes for reduction in water spread of Shanthisagara Lake in Davanagere district from the last 50 years using remote sensing and GIS techniques. The remote sensing data like Landsat-5 MSS, Landsat-7ETM and Resourcesat-2, LISS-IV were used to map the water spread area of the lake. Multidate satellite data analysis showed that there is change in lake water spread over the years. To know the reasons, rainfall data for more than 50 years were collected and analyzed along with land use/land cover studies carried out using LISS-IV data for the year 2009 and 2018. The result infers that there is a reduction in water spread area of Shanthisagara Lake over the years is due to reduction in rainfall in the catchment area, and significant change in land use/land cover pattern from year 2009 to 2018 has also contributed to reduced inflow to lake. Keywords: Shanthisagara Lake, water spread, remote sensing, GIS. Introduction. Lake is an area filled with water localized in a basin, which is surrounded by land, apart from any river or other outlet that serves to feed or drain the lake. Lakes lie on land and are not part of the ocean, and therefore are distinct from lagoons, and are also larger and deeper than ponds, though there are no official or scientific definitions. Lakes can be contrasted with rivers or streams, which are usually flowing. Most lakes are fed and drained by rivers and streams. Callas Elvinus al. 2018, natural lakes are generally found in mountainous areas, rift zones, and areas with ongoing glaciation. Other lakes are found in enderhikisons or along the courses of mature rivers. In some parts of the world, there are many lakes because of chaotic drainage patterns left over from the last ice age. All lakes are temporary over geologic time scales, as they will slowly fill in with sediments or spill out of the basin containing them. Many lakes are artificial and are constructed for industrial or agricultural use for hydroelectricity power generation or domestic water supply or for aesthetic, recreational purposes or other activities. Importance of the study. The study reveals the causes for the reduction of water spread area in the lake over the years using satellite remote sensing data from last 50 years, either rainfall over 50 years or the impact of LU/LC patterns changes in the lake catchment area. Data used. The change in the water spread area has been studied using multi-temporal satellite datasets used as given in Table 1. Software used. ArcGIS. ArcGIS is Geographic Information System developed by ESRI, Environmental System Research Institute, creates and analyzes geographic data, tests predictions, and ultimately makes better decision which allows a user to visualize and manage the database. ArcGIS is used by people all over the world to put geographic knowledge to work in government, business, science, education, and media. ArcGIS enables geographic information to be published so it can be accessed and used by anyone. ERDOSH Imagine. High-resolution images are used to analyze the land use/land cover changes using ERDOSH, because of the popularity and wide acceptance in remote sensing image classification. In this project, ERDOSH Imagine is used for the purpose of georeferencing. Results and discussion. In the Figure 1, satellite image is Corona acquired on March 14, 1964. This satellite image represents the Shanthisagara Lake water spread area is about 18.16 square kilometers out of 26.51 square kilometers of the boundary of Shanthisagara Lake. In the Figure 2, satellite image is Landsat-5 acquired on April 8, 1973. This satellite image represents the Shanthisagara Lake water spread area is about 22.73 square kilometers out of 26.51 square kilometers of the boundary of Shanthisagara Lake. In the Figure 3, satellite image is Landsat-7 acquired on March 23, 1999. This satellite image represents the Shanthisagara Lake water spread area is about 15.17 square kilometers out of 26.51 square kilometers of the boundary of Shanthisagara Lake. In the Figure 4, satellite image is Landsat-5 acquired on April 8, 2009. This satellite image represents the Shanthisagara Lake water spread area is about 12.69 square kilometers out of 26.51 square kilometers of the boundary of Shanthisagara Lake. In the Figure 5, satellite image is LISS-IV merged satellite acquired on October 8, 2017. This satellite image represents the Shanthisagara Lake water spread area is about 10.27 square kilometers and out of 26.51 square kilometers of the boundary of Shanthisagara Lake. Year. Annual rainfall of Chandigarh and Hollacar rain gauge stations from 1964 to 2017. The rainfall data from Indian Meteorological Department, IMD, website has been downloaded for the Chandigarh and Hollacar rain gauge stations from the year 1964 to 2017. The year-wise variation of annual rainfall for Chandigarh rain gauge station is shown in Figure 7, which reveals that the maximum amount of rainfall occurs in 1973 and the minimum amount of rainfall occurs in 2016 to 17. Similarly, for the Hollacar rain gauge station, annual rainfall variation is shown in Figure 8, where the maximum amount of rainfall occurs in 1972 and the minimum amount of rainfall occurs in 2016. From the above analysis, we can see a significant decrease in the rainfall in the catchment area over the years, contributing to the reduction in the water spread area. Land use land cover map, Fig 10, done for the considered study catchment area for the year 2007-09. LISS-IV satellite image is used. Visual image interpretation was utilized to classify the images to different land use categories. In order to classify the rectified images, 7 categories were delineated in the images, namely, plantation crop, agriculture fallow land, scrubland, forest, built, upland and water bodies. Plantation crop is about 691.03 square kilometers, agriculture crop is about 244.27 square kilometers, agriculture fallow land is about 30.45 square kilometers, scrubland is about 95.40 square kilometers, forest is about 90.98 square kilometers, built upland is about 29.24 square kilometers, and water bodies is about 38.11 square kilometers. Conclusion. Remote sensing and GIS techniques are very useful to assess the change in water spread in LU/LC of given area. Multi-dated satellite data for the last 50 years has enabled mapping of watershed of Shanthisagara Lake. Rainfall analysis for the last 50 years showed that rainfall has reduced over the 50 years and it could be one of the reasons for the reduction in water spread area of the lake. Land use/land cover change analysis has shown that there is significant increase in plantation area and this is maybe one of the reasons for reduced inflow to the lake. The suggestion like desiltation of the streams, those connecting to the lake will enable to good flow of water to the lake which may leads to increase the water spread area.